Alright, in this video we're going to talk about a normal distribution. So we've kind of mentioned a normal distribution quite a few times already this unit. A normal distribution is a bell-shaped curve that shows how data is distributed from the mean. So we have x bar, which is your mean, and we have sigma, the Greek letter S, which stands for standard deviation. And then sometimes you might also see your mean as the Greek letter M, which is mu. Alright, so here's a normal curve, and it's broken down into sections. So the empirical rule for a normal model states that about 68% of the data falls within one standard deviation of the mean. So I have my mean, x bar, and then if I add one standard deviation to the right, or I subtract one standard deviation to the left, 68% of my data falls within that. Okay, and then if you break that down into two, because I have two sides, it's 34% each. So that highlighted section, 34% on both sides, or 68% overall. Then I have 95% of my data falls within two standard deviations. So if I go from my mean and I go over 2 to the right and over 2 to the left, within those two standard deviations, plus or minus the mean, 95% of my data will fall within that. And then 99.7% of my data will fall within 3 standard deviations of the mean. So if a value falls more than 3 standard deviations away from the mean, then we would definitely consider that an outlier. Alright, so create a normal distribution. The amount of cereal in a carton is listed as 18 ounces. A machine fills the cartons, and the amount filled follows a normal distribution with a mean of 18 ounces and a standard deviation of 0.2 ounces. Label the distribution. Alright, so I'm going to break it into plus or minus 3 standard deviations. So I'm going to go 3 standard deviations to the right and 3 standard deviations to the left. So my mean is 18, so the line down the center, I'm going to put 18. When I add one standard deviation, 0.2, I get 18.2. When I add another standard deviation, so 2 standard deviations, would be 18.4, and 3 standard deviations would be 18.6. Now if I subtract 0.2 from 18 and then 0.2 from 17.8 and 0.2 again, I get 3 standard deviations that are less than the mean. Alright, so I have my normal distribution, and I just kind of drew my lines up for each standard deviation to kind of block it off. So if I go from 17.8 to 18.2, 68% of my data falls within that window. If I go from 17.6 to 18.4, 95% of my data falls within that window. And if I go from 17.4 to 18.6, 99.7% of my data falls within that window. Alright, so using the example that we just did, find the probability that a carton of cereal contains less than its listed amount. Well, the listed amount is 18 ounces. Well, if it contains less than that, then it's on that side of the line going down the middle, so we would say that's about 50%. Alright, the next one. Find the probability that a carton of cereal contains between 18 ounces and 18.4 ounces. So if I take my model, and I'm going from 18 to 18.4, so that's the section highlighted in yellow, so that's from the mean, 2 standard deviations above the mean. So from the mean to 2 standard deviations more than the mean. Okay, well, that would be the 95%, but it's only half of that 95%. So 95% divided by 2. Or you could look at on your notes, the first sheet where I broke it into each section. So 68 is broken into 34 and 34. And then the next standard deviation is 13.5 and 13.5. So if I added 34% and 13.5%, I'd get 47.5%. And then the next one, it says find the probability that a carton of cereal contains between 17.6 ounces and 18.2 ounces. So I'm going to look at this one, breaking it down into the different, instead of 68, 95, 99.7, I'm going to break it into its halves, 34, 34, 13.5, 13.5, 2.35, 2.35. Alright, so find the probability that a carton contains between 17.6 ounces and 18.2 ounces. So that'd be everything in here. So that's 68% plus 13.5. Okay. Or it's 95% of the data. If you divided that in half, that'd give you the 13, and then you added back the 68. We could get that, or added in the 34. You have several options on how you could solve for it. Okay, so I would suggest you draw the model out, you highlight it, and then you kind of break it into its pieces and add them together. So 81.5%. Alright, the scores on a test given to all juniors in a school district are normally distributed with a mean of 74 and a standard deviation of 8. Find the probability that a randomly chosen junior has a score between 66 and 90. So I'm going to draw my model. I have a mean of 74, so I'm going to draw my line down the middle at 74. My standard deviation is 8, so I'm going to add 8 for each standard deviation I go over to the right, and I'm going to subtract 8 for each standard deviation I go over to the left. So, and there's my, when I break it into its percentages, so I have 82, 90, 98. When I subtract 8 each time, I get 66, 58, and 50. Alright, so I want to know what's the probability that a randomly chosen junior has a score between 66 and 90. Alright, so if it's 66 and 90, it'd be the 34% and the 34% and the 13.5%, which adds up to 81.5%. So 81.5% of randomly chosen juniors would fall within that 66 to 90. Alright.